Problem number 5. Team A and Team B played a series of games. The first team to win 3 games won the series. Each team was equally likely to win each game. There were no ties, and the outcomes of the individual games were independent. If Team B won the second game and Team A won the series, what is the probability that Team B won the first game of the series? Alright, well, let's look at what some of the possible outcomes could be. Alright, so the most number of games that they could play would be 5, right? Because eventually somebody's going to win 3. So, I mean, if A won all of the first 3 games, then they'd only play 3 games. But we know that's not true because B won the second game, okay? So now we know they have to have played at least 4 games, because if A won the first and the third and the fourth, then the series would be done. And other than that, they had to play 5 games to eventually get a winner of the series. Okay, so I'm going to take a look at, what are the possible arrangements of their wins, the A's and the B's. To say that, if I put B here, that means B won, and A would mean the A won. Okay, so we know that B won the second game and A won the series. Okay, so we know A has 3 wins, and you can look at, we have 4 spots to put the 3 A's. Okay, so essentially we have 1 spot where that'll be a B. All right, so let's just write out the possibilities. So if this was, first possibility would be A, B, A. Okay, that would mean that they stopped after 4 games. Let's say that B was in the first spot. So if you had B, B, A, that's another possibility. We could have A, B. Let's say that this is B, A. Okay. And let's say we have A, B, A, B, A. Okay. And I think that's all. So essentially, we've got the 3 A's distributed among these 4 spots in different ways. Now, here we'd have a B here, but we really didn't play that because A already won. So really that it doesn't exist. So it kind of looks like we've got 4 possibilities. So you might be tempted to think that the probability of let's see, we're asked to find the probability that B won the first game is just 1 out of 4. But if you look at this, they only played 4 games. Okay, so the probability of this outcome is, the probability, the first one is a half, the second one is a half, right? Because they're equally likely to win the game, right? Equally likely. So the probability of this first outcome is actually 1/16. Okay, because we only have 4 games that we played. Now these other ones, we have a 50-50 chance each time that either A or B is going to win the game. Okay, so all of these are 1/32. Okay, so really this is 2/32, and if we add that all up, oops, not 36, 30 seconds. And so if we were to add that all up, we'd have, what? We have 5 30 seconds. Okay. But remember now that, these 4 possible outcomes here are just a subset of all the possible outcomes. Okay, because really, there's 32 possible outcomes without any restrictions. Okay, we have 2 possible outcomes for the first game, 2 for the second, 2 for the third, and so on. So 2 to the 5th is just 32. So we have 32 possible outcomes. So that's why it comes out to be 5/32. But so, but that's that 5, that 5 out of 32 is actually just a subset of all the possible outcomes, because it's restricted to the cases where A won the series and B won the let's see, yeah, A won the series and B won the second game. Okay, so of those, if they played 5 games, then of those 32 possible outcomes, 5 of them meet this criteria, and only one of them has B as winning the first game. Okay, so now you might be wondering, you say it's 5 of them, because we could actually, if we just pretend that they're just going to play 5 games, okay, then this A, B, A could be broken up into A, B, A, and A, B, A, okay? So if we were to divide this up into equally likely outcomes, they would be these two, which really are just one because we would stop after four games. But if we played 5 games in order to get equally likely outcomes, then we'd have both of these cases, in addition to the other 3 I listed out: B, B, A, B, B, A, and A, B, A, B, A. Okay, so if we were going to list out equally likely outcomes, okay, then they would be, we would just assume that they play 5 games. All right. So this is a little tricky because it's really tempting to see, oh well, there's only 4 possible scenarios that meet this criteria, with A being winning the second game, and A winning the series. Okay, but you have to recognize that they're not equally likely outcomes. Actually, the outcome of A winning all the other games but the second is twice as likely as any one of these other scenarios. And it's only because they're playing fewer games in that scenario. Okay? So, and here, if we list them out like this, we do have equally likely outcomes. So if we actually played a full 5 games, then all of these scenarios are equally likely. Okay? And in each case, A wins the series. It's just that these 2 games are unnecessary because well, not 2 games, it's just the 2 outcomes for the last game. That last game was unnecessary because A already really won the series. Okay? So that's why the probability is 1/5, okay? Or 20%. Alright? So, that's a tricky one, but make sure that when you're looking at outcomes, that you're looking at equally likely outcomes is the key to this problem.